Okay, class, in this video we define the 6 trigonometric functions of theta for a right triangle. And so we're going to use what we know from section 2.2 to accomplish this task. In the diagram on the left, we have the angle theta drawn in a standard position. It is an acute angle between 0 and 90 degrees. Remember, the initial side goes along the positive x-axis, and the terminal side, right, it will then be in the first quadrant somewhere. And so the rotation from the initial side to the terminal side is less than 90 degrees, so that theta is an acute angle. The terminal side touches this circle of radius c units at the point AB. A is the x-coordinate, B is the y-coordinate. Okay, and so again, the radius of the circle, we're not using R to denote the radius, we're using the letter C. If I, from this point where the terminal side touches the circle, if I draw a vertical line down to the x-axis, I can form this right triangle. And here's the 90-degree angle, right? The right angle. The this side of the right triangle then is the hypotenuse, right? Because it's across from the 90-degree angle, and the length of the hypotenuse is equal to the radius of the circle, which is c units. The height of this leg of the right triangle is equal to the value of the y-coordinate b. And the length of this leg, the bottom leg of the right triangle, is a units, which is equal to the value of the x-coordinate a. So this is the adjacent side to theta, this is the opposite side to theta, and again, this is the hypotenuse. So using the definition of the 6 trigonometric functions of theta from section 2.2, we have sine theta is equal to b over c, which is the opposite side over the hypotenuse side. Cosine theta is equal to a over c, which is the adjacent side over the hypotenuse. And tangent theta is equal to b over a, which is equal to the opposite side over adjacent. Okay? So remember, in section 2.2, tangent theta is y over x, but y is equal to b in this case, and x is equal to a. And similarly for up here, right? Cosine theta in section 2.2 is x over r, but x is equal to a in this case, and r is equal to c. So to remember this relationship, right, you might find the acronym SOHCAHTOA beneficial. SOH in SOHCAHTOA comes from sine opposite hypotenuse. Ka in SOHCAHTOA comes from cosine adjacent hypotenuse, and TOA comes from tangent opposite adjacent. So SOHCAHTOA you might find beneficial, remembering. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, and so their definitions follow from up above. And one thing you want to remember, with a right triangle, the value of each of the trigonometric functions of theta are positive, are always positive.